Okay. Let me just share my screen. I'll share a blank Word document. See, for the next 1 or 2 sessions, that is today's as well as the next maybe session, little bit theoretical. See, it does not mean theoretical means the whole syllabus is going to be theoretical. After that, we'll have 100% practical of yours, because you need to build up on your theory for you to do some practical. Straight away, we start doing some practical, it is meaningless for us to do. So today we start off, see, and incidentally, please remember tomorrow at 6 in the evening, you got a MCQ test, online test. It's already been uploaded long back. I think for 3-4 days back, I put it on the canvas. Please see, you have to keep your ears and eyes wide open so that you see all the announcements and other things. And one of you may please take the onus of downloading the recording, which maybe after 1 or 2 hours after the completion of session, I can put the link on the canvas, download it, and you can share it with everybody. Otherwise, the thing totally vanishes. You know, in any case, it's only till tomorrow morning I'll be giving you the privilege of downloading the recording. If you do it, it's fine. If you don't do it also, it is fine. It is gone then. Okay.
One second. I'll
Yes.
do that part. I'll download it and hopefully I'll upload it as discussed with you on a YouTube. Last week class is with me, and today's class, when you download, when you send a notice, I'll get a notification. I'll download and I'll do the needful by today evening.
Done, sir. Done. Okay.
Thank you very much.
Okay. Let's see a little bit on the history of blockchain. See, and in any case, as part of your MCQ, which we will be having tomorrow, you will be having only the ones which we have covered till today. Nothing more than this. Don't worry. Blockchain, see, you must have heard of this concept. The minute somebody says blockchain, you think it is Bitcoin. It is one way correct as well as not correct. See, when minute blockchain had started, it had actually started off with Bitcoin. The founder, or you can say the grandfather of blockchain is or Bitcoin is a person by the name of Satoshi Nakamoto, a Japanese person. But till today, nobody in whole of this world has ever even seen him. People have just heard his name, that there's somebody by the name of Satoshi Nakamoto. Nobody has ever seen him, nothing of that kind. So he remains maybe something like a pen friend or something. But still today, everybody considers that the inventor of blockchain or Bitcoin is Satoshi Nakamoto. And blockchain was the first, Bitcoin was the first thing which started off when blockchain was invented. And when you go into the brief history of this blockchain, somewhere in 90s, one person by the name of Haber, the other person by the name of Scott. And somewhere in 98, the computer scientists worked on something called as a bit gold, a decentralized digital currency. And then in 2000, there's a person by the name of Stefan published his theory of cryptographic secured chains plus the ideas for implementation. And in 2009, Satoshi Nakamoto implemented the first blockchain as a public ledger for transaction which was made purely using bitcoins. And somewhere in 14-15, blockchain technology was separated from this Bitcoin and its potential for other financial inter-organizational transaction, and the concept of blockchain 2.0 was born. That is, I shall just write it for you. Blockchain 2.0 originated somewhere around 2014. See, the Ethereum blockchain system introduces computer programs into the blocks, representing some financial instruments such as bonds, and these become known as smart contracts. See, posting this somewhere in 2009, when this initial code for this Bitcoin was launched by Satoshi Nakamoto without the need for a central bank. The beauty of Bitcoin is you don't need a central authority in Bitcoin. It is without any central authority, the transactions go on in Bitcoin. While it wasn't the first online currency to be proposed, the Bitcoin proposal solved many problems in the field and has been by far the most successful version. See, the engine that runs the Bitcoin ledger that Nakamoto designed was called the blockchain. Please understand this in bold and capital. the engine which runs the Bitcoin ledger that Satoshi Nakamoto designed was called the blockchain. And the original and largest blockchain is the one that still orchestrates Bitcoin transaction even today. Then came the second generation of blockchain. See, the other blockchain includes those that run the several hundred of nodes which are called as altcoin. This was the second generation of blockchain. I shall just write it for you. It is altcoins. This is the second generation of blockchain. As well as it was used in many different applications, such as it was used in Ethereum, and also it was used in Ripple. Ethereum is the second largest blockchain implementation after Bitcoin. And Ethereum, it distributes a currency what is called as Ether. We will definitely look into details of this Ether, but in some other module, not in the introduction part. Right now, you can understand the largest blockchain implementation is Ethereum, and Ethereum distributes a currency called Ether, but also allows for the storage and operation of computer code and basically allowing for smart contract. Ripple is nothing but a real-time gross settlement system. Ripple is nothing but a real-time gross settlement system, currency exchange and remittance network, which is based on a public ledger. There are some challenges to Bitcoin blockchain, like any system. Any system which is launched for the first time, definitely there are many challenges, and even blockchain has got many challenges. Blockchain is touted as one of the most revolutionary technologies of the current time. And blockchain technology has the potential to make transactions more secure and transparent and stakeholders more accountable. There are, however, quite a lot of challenges that need to be addressed before large-scale adoption of blockchain is possible. And the first and the foremost among that is scalability, which is one of the key challenges in blockchain implementation is its inability to scale. See, networks like this Bitcoin and Ethereum experience a slowing down of transactions and a consequent increase in the transaction fees as more users join the network. See, blockchain networks are slow, while Bitcoin blockchain can process around 3 to 7 transactions per second. The corresponding figure for Ethereum blockchain is not more than 15 to 20 transactions. This makes blockchain unviably the large-scale application. See, on the contrary, legacy transaction systems such as this Visa, it can handle around 24,000 transactions per second. So blockchain need to speed up in order to become viable for mass adoption. The second issue which needed to be addressed was energy consumption. See, blockchain requires high degree of computational power, and hence it requires massive amount of electricity. The blockchain network, be it Bitcoin or Ethereum, use something called as POW, means proof of work. POW, proof of work, which is to validate the transaction and add them to the network. In a blockchain, miners are the people who pick up a block of transaction and try to generate the right hash output for the block. And this process relies on complex cryptography and solving of complex mathematical problems. And as a result, there's a lot of electricity is needed to fuel the computers that are involved in this. The Bitcoin ecosystem consumes around 0.2% of the global electricity currently, as on today. And going by this rate, it is estimated that maybe by end of this year, Bitcoin users will use more electricity than the entire world that uses as on today. And the third thing which it needs to satisfy is lack of standardization. See, with so many platforms present in the blockchain space, there is currently no standard that allows them to interact with each other. There are thousands of active blockchain projects today running on different platforms, and each of these platforms has its own coding language, set of protocols, and consensus mechanism. It is very difficult for the platforms to interact with each other without a translator in between. And organizations are working to develop a standard version of the blockchain to improve this cross-platform collaboration. And another one problem with blockchain, as you know, is association with cybercrime. And since right from the time when blockchain has been developed, blockchain has been known to be associated with criminal activities. Even today, you must be watching TV where one of the very prominent news as on today is the Sushant Singh murder case. In that also, it is told that the entire drug dealing in India, in our country, as on today, is through the darknet, which is pure, just using cryptocurrencies. There, because there is no accountability for where you're buying the drugs, who are you selling it to, who is the customer, or who is the person who supplied it. You place the order under trust, and he delivers the things to you, whatever you want. So there is a big association of blockchain with cyber criminals. See, cyber criminals have been known to sell drugs, weapons, and several banned items very, very conveniently and anonymously using Bitcoin. And Bitcoin has been extensively used in money laundering and ransomware payment. See, terrorist organizations have been known to campaign for Bitcoin funding on social media platforms. And to make Bitcoin acceptable to the masses, the criminal association has to keep going. The other issue is privacy. See, this public blockchain raises some key concerns that needs to be addressed. And all public blockchain are open electronic ledgers where all the transactions are visible to all the servers. While this feature may be beneficial where transparency is desirable, it can become a liability in environments that have stringent privacy requirements. And for example, the medical records, say, of a patient cannot be made public under any circumstances. And same goes for any kind of government data. And as most of the applications in any industry entail a certain degree of privacy, public blockchains need to be modified to restrict access to authorized persons only. And then the other issue can be of security. See, all the public blockchains are vulnerable to what is called as 51% attack. And all this, we had seen this, what is this 51% attack in our last session, that is the last Saturday. All the transactions happening on a blockchain have to be validated by the majority of miners present in the network. And if any miner or group of miners gain control of 51% of the nodes on the network, they can prevent other miners from creating new blocks and hinder the validation of new transactions. They can even reverse the transactions confirmed by them. And the possibility of this attack, however, decreases as more miners join the blockchain network. The other contentious issue is on cost. See, any blockchain network needs computers with high degree of computational power. So this blockchain technology does not come cheap. Large-scale implementation of blockchain will involve its integration with legacy systems, which is definitely expensive. And these are all the issues which are in and around blockchain, and all governments in the world are trying to regulate blockchain. In our country, in India, as per the regulation, although government had declared the cryptocurrency as a banned entity, it was in 2019 March, Supreme Court had given a adverse ruling saying that cryptocurrency in India is valid. It is a valid currency. There are not even if the government tries to regulate blockchain, there are issues. For example, what if the blockchain comply with regulations today but fail tomorrow? No one will be able to update them as blockchains are immutable. immutability of blockchains make their regulation very difficult. So this gets us to some very important, I would say, definitions or concepts which you should know. The first is what is blockchain identity. In identity management, a distributed ledger, which is a blockchain, enables everyone in the network to have the same source of truth about which credentials are valid and who attested to the validity of the data inside the credentials without revealing the actual data. Once again, in blockchain identity, in this identity management and blockchain, a distributed ledger, which is a blockchain, enables everyone in the network to have the same source of truth about which credentials are valid and who attested to the validity of the data inside the credentials without revealing the actual data. The other concept which you need to know before going ahead is digital signature. See, a digital signature you definitely must have heard or learned as part of your course with ISL. A digital signature is a mathematical technique which is used to validate the authenticity and integrity of a message, software, or digital document. Once again, a digital signature is nothing but a mathematical technique which is used to validate the authenticity and integrity of a message, software, or digital document. Keeping all these things, let's discuss a little bit more about digital signature. See, a digital signature is the detail of an electronic document that is used to identify the person transmitting the data. Digital signature makes it possible to ascertain the non-distortion status of information in a document belongs to the key certificate holder. The details value is a result of the cryptographic transaction of information through the use of a public and private key. Digital signature is treated as a substitute for handwritten signature to the extent permitted by law. In respect to the document being transmitted, whenever a document gets exposed to a malicious modification, the signature is invalidated since it conforms solely to the initial document status. And digital signature guarantees protection from falsification. The existing signature algorithm renders falsification infeasible in most of the cases. And digital signature ensures non-repudiation of the origin. That is, any signature is generated using a private key that is known only to its owner, who is therefore unable to repudiate his or her signature after the document. There are some digital signature algorithms, which I shall just write it out for you. These are DSA, digital signature algorithms. And the first one, you must have heard of it, it is RSA, which is the most secured algorithm as on today anywhere in the world. There are two algorithms which are foolproof. That is, nobody has been able to crack it. First is RSA and the second is NTRU. RSA is by the name of three scientists who had devised it. It is Dr. Rivest, Dr. Shamir, and Dr. Edelman. Out of this, one gentleman happens to be an Indian. NTRU is a research lab in the United States. These signatures, these algorithms are so foolproof that it has been a few years since it has come into the world, and physically nobody has been able to decode it. That is why all big multinational companies like EMC Square, Infosys, Wipro, almost all big companies use RSA. It is a wonderful algorithm. It comes at a price. It is not free. It is not free. We will see as we proceed how do we build algorithms, or how do we play around with algorithms. But as you had told in the last session that you have not been exposed to this computer algorithms, fine, no problem. I shall keep it in mind. We shall give you a knowledge of how do you do this encryption decryption process. It's another wonderful thing. Okay, now if a message is in RSA algorithm, this is a public key encryption algorithm. See, there are two encryption algorithms which are prevalent in the nature. One is public key, one is private key. Private key means, say I am from here, I am sitting in Bangalore, I want to share some information with you guys at Hyderabad. What I'll do, I'll take my message, apply some key, lock it. And with that key, I shall pass it through any means to you people so that you are able to open it and read my message. This becomes a private key because the key is hidden. Nobody knows. And how I transmit it? Maybe I take a runner from Bangalore, I tell a friend, you travel by air, go to Hyderabad, go to ISL college, which is near the airport, give them this key icon, they'll be able to unlock the message. Or I can ask one of you to come down to Bangalore, I give you the key, any of this way. Whereas public key encryption is what I do, I lock my message with a key. And this key, I make it available to the public. Nobody is still able to open it because you don't know how many, it is something like the door of your house. How many times I have to give a clockwise turn, how many times anti-clockwise, mix and match all this. Nobody knows it. So that becomes a public key algorithm. And if you see in terms of security, the most secure are public key algorithm. Similar way, this RSA is also a public key encryption technique. And the security feature of this algorithm stems from directly of the factorization problem. The algorithm employs two keys, that is the public and the private key, forming the relevant pair. The public key is used for data encryption purposes. And if a message is encrypted using public key, then it can be decrypted using the associated private key. That is what is RSA algorithm. Once again, if you're not understood, see, RSA algorithm is a public key encryption algorithm. The security features of this algorithm stems from the difficulty of the factorization problem. How to factorize it, that is difficult. They use a 512-bit algorithm. The algorithm employs two keys, the public key and the private key, forming the relevant pair. See, and the public key is used for data encryption purpose. Now, if a message is encrypted using a public key, then it can be decrypted using the associated private key. Now, there are some advantages and disadvantages of this RSA algorithm. Advantages is it is convenient distribution. Advantages is the convenient distribution of public key. So there is no secrecy because minute you say there's something secret within the algorithm, people try to break it. There is nothing secret. The key by which you lock, he makes it available to the public. Still, you are not able to decrypt it. Other advantages, the bigger networks have much smaller number of keys. That is a symmetric crypto system. And the disadvantages, RSA algorithm has low operating speed and it has high computing cost in connection with ensuring encryption strength relative to falsification attempts. And RSA is susceptible to multiplicative attacks. In other words, it allows a malicious user who does not know a secret key to generate a signature for the documents. See, the RSA system is used in hybrid crypto systems in combination with symmetric algorithms. RSA is employed by Microsoft, Apple, EMC Square, Sun, Novel Networks, and the hardware application of RSA algorithm includes some voice telephones, Ethernet network cards, smart cards, large-scale application in cryptographic equipment. See, you all must have watched on TV the aircraft which is used by the President of the United States. Although he might be flying at 30, 40,000 feet above the sea level, still he is able to communicate with anybody, anywhere in the world. How? And he uses a telephone to communicate. And all of you know, wireless communication is the most insecure form of communication. But his communication is very, very secure. Why? It is because he employs RSA encryption technique. Nobody is able to break it. Nobody can even hear it. No question of eavesdropper in between, somebody taking away his messages, what he wants to communicate with somebody. This now what we are seeing, this are some of the digital signature algorithm. The first one, digital signature algorithm, is RSA. The second one we shall see is Lkml encryption system. Lkml encryption system, which is single M. Lkml encryption system. See, this is another public key encryption algorithm. The security features of this algorithm stems from the difficulty of computing discrete logarithms in the finite field. The Lkml encryption system encompasses both encryption and digital signature algorithms. There are some advantages of this Lkml encryption system as well as some disadvantages. The advantages are it is the probabilistic nature of encryption, offering high strength level. Also is the ability to generate digital signatures for a large number of messages using just one secret key. Disadvantages being doubling of the encrypted text length as compared with the initial one, causing longer computing time and tougher requirements for communication channel security. And this solution of this Lkml encryption system is employed in public key certificates for the purpose of protecting connections. The next one kind of encryption algorithm for digital signature, what is widely used is DSA. DSA is a public key encryption algorithm designated to create an electronic signature. A signature is created in private, but it can be verified in public. That is, there are some advantages of this DSA over this Lkml encryption algorithm. That is, it is and lower signature computation speed and reduced required storage space. Some disadvantage being the signature verification must entail complicated reminder operators. There are few other wonderful algorithms which are used. We shall just see last one of them, which is EDDSA algorithm, which is another one which is very prominently used. It is written as EDDSA algorithm. See, this is a signature scheme with employment of Schnorr option and elliptical curves. This EDDSA algorithm, this relies on this EDDSA algorithm. This relies on ED 25519 signature scheme, which is based on SHA 512 or 256 and the curve 25519. Once again, this EDDSA algorithm, which is also used for digital signature, is in this there is a signature scheme with employment of Schnorr option and elliptical curves. This EDDSA algorithm relies on ED 25519 signature scheme, which is based on SHA 512 or SHA 256 and curve 25519. Some advantages are this is high speed, independence of random number generator, and high performance. These are some benefits of EDDSA. Going little bit ahead with EDDSA, with this digital signatures. See, once again, let me repeat it. Digital signature is a mathematical scheme for verifying the authenticity of digital messages or document. A valid digital signature where prerequisites are satisfied give a recipient very strong reason to believe that the message was created by a known sender and that the message was not altered in transit. Now, what I will do, I'll just show you pictorially how is this encryption done, or is it that you have got a maybe a rough idea of how an encryption is done using public and private key? If you have got it, I shall not show you, or otherwise I shall show it to you. One of you may please tell me. Tell me, how about your knowledge on encryption? What is it? How encryption or how a decryption is done? Do you want me to show it to you, or you know it how it is done? As part of your engineering, you have done it in some semester. Tell me, please.
Done it, sir.
Okay, fine. I should just show it to you. Let me just connect up my digital pad and I share this Google Canvas. Give me just a minute's time. Okay. Now, see, whenever you learn about encryption, decryption, there are two characters which are very prominently used, Alice and Bob. Let's presume I have my friend Alice here. He wants to transmit a message to Bob. What Alice does, say he transmits a message, let's say, hello Bob. This message, Alice, what he does, he digitally signs it. I just write DS. And after here, when he digitally signs it, Alice inserts his private key. This becomes Alice private key. With the private key of Alice, he puts a signature transmitted. It is all garbled message. And you very well must be knowing how a message is transmitted, which I'll tell you immediately after this. So here, this message is transmitted. It arrives at Bob's territory or the Bob's place. Bob, what he does, he verifies the message using Alice public key. Using Alice public key, he verifies the message and he gets the wrong message, which is nothing but hello Bob. This is how a message is encrypted or decrypted. Now, something over here in between, I said it is in a garbled form. What does that mean? Can somebody tell me? Or can somebody tell me, in order to understand this concept better, how is it that a message is transmitted from here to any place to any place? Say today you sitting in Hyderabad, pick up your mobile phone, speak to your friend maybe in US or Australia. How is it that the message goes to him in US or Australia? Can somebody help me out, please? Anybody, tell me, please. I hope you got my question. You pick up your mobile phone sitting at Hyderabad and you want to speak to some friend of yours in Australia, US, or maybe Bangalore or anywhere in India abroad. How is it that the message is transmitted? Tell me, somebody tell me. Say I've got one person, Alice. He is in Hyderabad. Alice wants to speak to Bob, who is, let me say, in Australia. How is it that the message goes from Alice to Bob and back from Bob to Alice? How? Anybody tell me. If you don't know, tell me. No, I don't know. That's fine.
Through virtual connection.
How? That means whoever answered now, there are a lot of this A, B, C, D and other things floating in the air. Can you do one thing for me? Give me about 10,000 A and some 20,000 B and 30,000 Z. Put it in a gunny bag and give it to me. I'll come to Hyderabad and pick it up. Can you do that? Because you said there's so many things floating in the air. Full stop, comma,
Yes.
apostrophe, exclamation. So many are floating in there. Am I right or wrong?
Yes, sir.
Okay. So can you catch hold of some 100 A's right now? And some
So we
200
need to
Z?
make a tunnel, maybe a tunnel.
Oh, and you'll be able to catch it. Sorry?
Electronic signal, sir.
Electronic signal. That means there are a lot of signal on top. I put my hand in the air, I'm going to get an electric current.
No,
But
not like that, sir.
I don't get any electric current. I'm using a digital pad. I'm still not getting any electric shock or anything. There are so many electric signals in the air, isn't it? Tell me, push yourself. You're going to finish your engineering. Fundamentals, you should be very clear with your fundamentals. Anybody else?
Earlier, wires and cables were used for physical communication, and now they are using cellular network for telecommunication.
Okay, that means Sadaf, when I have Alice wanting to communicate with Bob, Alice who is in Hyderabad to Bob who is in Australia, and Alice is earlier through the wire, we used to take A, B, C, D, E and throw it inside the wire. Now we throw it in
No,
the
sir.
air.
Nowadays we have towers over here. So the communication is through different networks. Communicate and
No,
then
no, I
they are
understood. See,
connected.
I want to know. See, I want to know the very fundamental thing. I don't understand all this big concept. That means, say, A wants to communicate something to Australia, which is across the sea. What A will do, A will take, he'll stand on his terrace and he'll throw alphabets one after another for the tower to catch. And this tower throws it back to Bob. Is it that? How many times did you throw all these alphabets today? Ever since you woke up in the morning? That means if the tower is far from your house, you have to throw it very hard. Am I right or wrong? Say the tower nearest to your house is maybe 4 or 5 kilometers. You have to throw it very hard for the tower to catch it. If the tower doesn't catch it, that means the signal is gone. Is it that way? But nobody tell me. Unless you speak, how will you get to learn?
No,
We
sir.
don't know, sir.
Nee, tell me. See, that's what you said. Take ABC. If I want you, that means if I want you to transmit HELLO, first you will catch hold of H and throw it high in the air. Then E, you throw it in the air. L, you throw in the air. Then L, then O. All of these things are caught by the tower. And if there's a rain or lightning, some of the things get missed. So in hello, when it reaches Bob, he might just hear LLO. HE has got eaten up. Is it that way?
No, sir.
Then
Sir, basically it's internet connection, how everything is working, and then that's how basically everybody communicates.
how?
Internet.
I want to know. See, or is it some magic? Some magic happens in there. Well, that means earlier you say, earlier we had electric wires. Say that means if I want to pass hello, first I take H and push it in the wire. Then I push E behind. Then another E behind. Then another L. Then another L. And then last O. I push all of this in the wire.
Sir, not like that, sir. These alphabets will be converted in electronic signal. For example, 0 and 1 bits. For every letter, there is assigned binary letters like that.
Who assigns it? Who assigns it?
The phone we are talking in this.
Okay, phone assigns it. That means BSNL has got some 0 and 1 different. Airtel has got something different. Is it?
Sir, everyone uses the same bits, 0 and 1.
Then tell me one thing, then why is it that there is no cross call or anything? Say you speak to some friend of yours, somebody else should be able to comfortably hear what you're speaking. Because everybody uses the same 0 and 1.
Just like you have said, we use cryptography to secure connection between A and B. That's why.
No. If I may tell you, all your fundamentals are a big. My canvas,
Sorry, your voice is breaking, sir.
So I would use the word drama, and it's a wonderful drama that happens. Say like we had taken two people, Alice and Bob. Alice wanting to communicate, let's say HELLO. In this H is capital, rest all are sentence keys. What happens? All the words of alphabet. So you cannot take H and throw it inside a wire. Or you cannot have like Sadav going to the terrace and throwing H very hard so that the tower catches it. You cannot have Sadav going to the terrace and throwing H so that the tower catches it and tower throws it from there to Bob. That also is not possible. All of these alphabets from A to Z or small a to Z, full stop, comma, space bar, everything has got an ASCII equivalent. American Standard Code for Information Interchange. All those of you who have worked with the erstwhile Fox Pro, in Fox Pro there is a help option which gives you the ASCII equivalent of all the things. Now you don't require it. You just Google it, ASCII equivalent for all numbers you get it. For A, it is 97. So although even the value of A being 97, you cannot pass a 97 through a wire. What you do, this 97, you do binary encoding. That means your result is only in 0 and 1. And this, when you do binary encoding, you can do a 8-bit binary encoding, 16-bit, 8, 16, 32, 64, all of these are insecure. The higher the number of bits, that accurate it is. RSA uses something like 512 bits. Nobody till today has tried anything more than 512, that is 1024 bits. Nobody has tried it. You guys try it. If it is successful, you get a patent on your name. It is very difficult, very, very difficult, even if it is 512 bit. So what you do a binary encoding of this, convert all of this to 0 and 1. Now 0 and 1 also I cannot pass it through a wire, whether it is a wire or a wireless media. 0 means low voltage, 1 means high voltage. That's all. It is low and high voltage which is passed through it. That's all what is done. From here, what you do, the message from Alice goes to the tower where this message is encoded. And this is passed to the tower of B where the message is, this is encrypted and the other side it is decrypted. And the message as spots, plain text, is passed on to B. That's all what happens. There is no question of even you going to the terrace and throwing H very hard or very slow, makes no difference. And if you get into the concept of encryption cryptography, the earliest known cryptography was what is called as Morse code. So you may today at the end of the class just Google it and see what is Morse code. This is the manual way of passing message. Even today, this method is practiced by most of the countries. Even our government of India practices this Morse code, wherein you find a person standing with two flags, one flag on both his hands, one flag on one hand, other flag on another hand. With this, he waves the flag so that the person from the other end, what he does, seeing the position of the flag, he keeps telling alphabets what it pertains to another person who stands beside him, and then he truncates this. He tells what is the sentence which needs to be passed on. This one, or now what is done, we will, as part of this course, do a small little exercise on encryption, which will be a wonderful way of encryption. And like what is my this thing, we will have the same encryption algorithm which you develop implemented in your college, so that whenever, say, you want to pass on from your college, say, the results to Osmania University, nobody in between is able to wiretap it. We will use your algorithm, what you will be developing in due course of time, encrypt your message, and over there at Osmania University, they will decrypt the message, get the original message. It is a wonderful technique. It is purely mathematics. And extensively what is used is the modulo operator, mod. We will do it, definitely we will do it 1, 2, 3, 4 examples. But before that, I thought, let me explain to you what these concepts are. This is how any encryption anywhere in the world goes on. See, these digital signature, is this clear to you, Tivya, or how do you do encryption and decryption? Anybody, any doubt on this? Tell me. Feel free and you tell me. Fine, is it fine?
Yes, sir, it's fine.
Okay. See, the digital signatures are a standard element of most cryptographic protocol suites and are commonly used for software distribution, financial transaction, contract management software, and in other cases where it is important to detect forgery or tampering. Digital signatures are often used to implement electronic signatures, which include any electronic data that carries the intent of a signature. There are two kinds of cryptography which I will want you to learn it on your own. We will also see what it is. One is the symmetric cryptography, the other is the asymmetric cryptography. Digital signatures employ asymmetric cryptography. In asymmetric cryptography, the key which is used for encryption and decryption is different. Whereas it is the same key which is used and decryption. So, if more security, you use asymmetric cryptography, where the keys are different. And in many instances, what these digital signatures do, they provide a layer of validation and security to message to the messages sent through a non-secure channel. So this is all that what you need to understand on digital signature. There's another one very important topic which I want you to understand before we get into this big game of blockchains and cryptography on this concept of hashing. Do you know what is hashing? What is hashing? Very, very
Yes, sir.
important in yeah, tell me.
We take a data and we, by using hash function, we assign a key to it and we place it in the directory so that
Yeah,
when we come later, we can easily access it.
okay. But you should know, if you want to develop wonderful algorithms, you should know what is hashing. How do you do hashing? And you have to master, if you're using Python as your tool, you have to master this Python hash functions. See, hashing is generating a value or values from a string of text using mathematical function. And hashing is one way to enable security during the process of message transmission when the message is intended for a particular recipient only. See, a formula generates a hash which helps to protect the signature of the transmission against tampering. See, it is very important to know how blockchain hashing works. And in order to do that, we need to first understand one of the core principles that go into blockchain creation. Blockchain technology is one of the most innovative and era-defining discoveries of this last century. So what is this hashing? In very simple words, hashing means taking an input string of any length and giving out an output of fixed length. That's all. You take the input of any length, give out an output of fixed length. That is what is hashing. And in the context of cryptocurrencies like this Bitcoin, the transactions are taken as input and run through a hashing algorithm. And in Bitcoin, please remember the hashing algorithm that is used is SHA 256. This is the hashing algorithm which is used anywhere in Bitcoin. Till now, they are not implemented 512 because it is extremely difficult to have SHA secure hash algorithm. See, and in this case of Bitcoins, cryptocurrency like this Bitcoin, the transactions are taken as input and run through a hashing algorithm which gives an output of fixed length. So we will see how this hashing function works. See, a cryptographic hash function is a special case of hash function that has various properties making it ideal for cryptography. There are certain properties that a cryptographic hash function needs to have in order to be considered secure. We will run through them one by one. The first is deterministic, which means that no matter how many times you pass through a particular input through a hash function, you will always get the same result. And this is critical because if you get different hashes every single time, it will be impossible to keep track of the input. Then the other one is quick computation. Here, the hash function should be capable of returning the hash of input very quickly. And if the process isn't fast enough, then the system simply won't be efficient. Then even you have got on the concept of pre-image resistance. See, what this pre-image resistance states is that given h of a, I say given h of a, it is infeasible to determine a, where a is the input and h of a is the output hash. You need to notice the use of the word infeasible. I use infeasible and not impossible. We already know that it is not impossible to determine the original input from the hash value. Let's take a small example. I want you guys to help me solve it. Suppose you are rolling a dice and the output is the hash of the number that comes up from the dice. The face which is on top, it is the output, the hash of that number. How will you be able to determine what the original number was? Who can help me out with this? I said I take a die, a 6-face die. I roll the die and whichever face of the die which comes on top, the face of the die which comes on top, how will you, and I create a hash of that. How will you be able to determine, and you are some other person who might tell you, I give you the hash function. How will you be able to determine what the original number was? Then anybody try it out? See, I've got a die. 6 faces. Okay, I roll the die. Say this face comes on top. Let's presume it's number 5. I create a hash of this number 5 and I pass it to somebody. Say I pass it to Razak. And I ask Razak, what is this number? How will Razak tell me which is this number? Or what should Razak do? Tell me, try it, no problem. At the max, you can be wrong, nothing more than that can happen. How come your participation is very low today? What happened? See, it's very simple. All that you have to do is find out the hash of all numbers from 1 to 6 and compare. Since the hash functions are deterministic, the hash of a particular input will always be the same. So you can simply compare the hash and find out the original input. That's all. But this only works when the given amount of data is less. See, in this case of a die, I know there are only 6 faces. The data is less. I can compare 1 to 1 and say which is this number. What happens when you have huge amount of data? Suppose you're dealing with, say, a 128-bit hash. So how will you find out what is the original input? See, in this die which I showed you, here we have just got 6 faces. I can take the hash of all the faces, compare it with what has been given to Razak. And Razak will tell me it's a smart approach. He will tell me this is the original number. Now, this is because it's a small number of input. Say I am dealing with a 128-bit hash. How will I do it? What should I do? How do you get the original value using a 128-bit hash? The only way you can do it is brute force method. See, the brute force method means that you have to pick up a random input, hash it, and then compare the output with the target hash and repeat until you find a match. So the only way you can do is brute force approach. Fine. Let me just open one more canvas. There is one more very important. Anybody not understanding anything, you can stop me anytime, anywhere, and ask me what it is. One more very important thing which I want you to understand is what is a birthday paradox. Say if you meet any random stranger out on the streets, the chances are very low for both of you to have a same birthday. And in fact, assuming that all days of the year have the same likelihood of having a birthday, the chance of another person sharing your birthday will be 1 by 365, which is nothing but 0.27%. So it is very, very, very low. However, if you gather, say, I said 20 to 30 people in one room, the odds of two people sharing the exact same birthday rises. In fact, there is a 50-50 chance for two people sharing the same birthday in this scenario. Why does this happen? Can somebody tell me? Say I have 20-30 people, and I'll say the chances of two people having the same birthday is around 50-50. Why? Tell me, somebody help me out. Is it that you're there? Is it that you got disconnected? I really don't know if you don't speak out. And this subject, although we are in the extreme basic as of now, this subject is little demanding. Means you'll have to put in good amount of efforts for you or by yourself. See, the reason why does this happen is simple rule of probability. Simple rule of probability which says, suppose you have n different probability of an event happening, then you need square root of n random items for them to have a 50% chance of a collision. It is the simple rule of probability. Once again, I said I take a room of about 20-30 people. The chance of two people having the same birthday will be maybe around 50-50. Why? It is because of the simple rule in probability. It says, suppose you are having n different probability of an event happening. Then what you need is you need square root of n random items for them to have a 50% chance of a collision. So applying this theory for birthdays, you have 365 different possibilities of birthday. So you need square root of 365, which is approximately, I think, 23. That means there is 23 randomly chosen people for 50% chance of two people sharing the birthday, sharing the same birthday. Have you got this, or you want me to tell you once again? Tell me why. See, this concept of the concept of the concept of blockchain is not. It involves intense amount of mathematics, intense amount of probability theory, good amount of everything. See, had it been so simple, it would have been a cup of cake for everybody. It is not so simple, but it is not even difficult, I would say. Now, the question that comes is, what is the application of this in hashing? Say you have a 128-bit hash which has 2 raised to the power 128 different possibilities. And by using this birthday paradox, which we just saw some time back, you have 50% chance to break the collision resistance at this 2 raised to power 128, which is nothing but 2 raised to power 64th instance. As you can see, it is much easier to break collision resistance than it is to break pre-image resistance. No hash function is collision free, but it usually takes so long to find a collision. So if you are using a function like SHA-256, it is safe to assume that H of A equal to H of B. So what you can say, A equal to B. This is the application of this concept, this birthday paradox in hashing. And this is very, very wonderful, puzzle friendly. This is a wonderful property of this. And the application and impact that this one property has had on cryptocurrency is huge. What we will do, we will define the property, and after that, we will go over each term in detail. Now, for every output, say I say Y, if I have K, which is chosen from a distribution with high minimum entropy, it is infeasible to find an input X such that h of k given x equal to y. That probably, I would say, would have slightly gone over your head. Am I right or wrong? Or were you able to digest this?
I didn't get it, sir.
Yeah, sorry? I didn't get you.
Get it, sir.
Okay. Now I said, see, the application and impact of this property which we saw earlier on cryptocurrency is huge. Now for this, we to define this property, let's see right from ground zero. I said for every output y, if suppose I choose k from a distribution with high minimum entropy, it is infeasible to find an input x such that h of k given x equal to y. Don't worry, I will tell you what do I mean by this high minimum entropy. I'll break down all this what I've written over here. High minimum entropy means that the distribution from which the value is chosen is hugely distributed. So much so that us choosing a random value has a negligible probability. Basically, if you were told to choose a number, say between 1 and 5, that's a low minimum entropy distribution. However, if you were to choose a number between maybe 1 and a gazillion, that is a high minimum entropy distribution. Once again, see, high minimum entropy distribution means that the distribution from which the value is chosen is hugely distributed, so much so that choosing a random variable has a negligible probability. That is, if I have got huge amount of choices from which I have to choose a number, it becomes comfortable. Say I want to choose a number between 1 to 1 million. It is pretty simple. Whereas if I say I want to choose a number from 1 to 5, it has got low minimum entropy distribution. The other thing which I said over here is k given x. This sign, do you know what is the sign? It is a pipe symbol which is on top of return. Mathematically, it is called as a pipe symbol. Have you heard of this pipe symbol? Yes or no? Bolo bhai.
No, sir.
Okay, this is a pipe symbol or it denotes concatenation. Concatenation means, adding two strings together. So what we will do, we will revise the same thing what we have done. So let me open a different canvas so that I'm able to explain it better. Suppose you have an output value, I say y. If you choose a random value, say k, from a wide distribution, it is infeasible to find a value x such that the hash of the concatenation of k and x will give the output y. Once again, I use infeasible and not impossible because people do this all the time. Understood, not understood. A simple example, say I've got two words, blue and sky. If I concatenate this, what will happen? If I concatenate these two, what is going to happen as my output?
Blue
It will be blue sky.
Yeah.
Blue sky. Similar way, I have revisited this definition. Say I have got an output value y. I have got an output value y. Now, if you choose a random value, say k, from a wide distribution, it is infeasible to find a value x such that the hash of the concatenation of k and x will give the output y. Some examples, if I can say, of cryptographic hash function is MD5. MD is acronym for Message Digest 5. And MD5 produces what is known as a 128-bit hash. Many of the hash functions are there. We will take example, we will do encryption and see how well or how not well we are going to do. Having understood, have you understood till here? Bolo bhai, yes, no. See, definitely what is involved, it is not just attending this session. You have to also, although we have got session just 2 times a week, you have to also put in efforts, pull out some books, not from the internet. Definitely you need published books, pull out some published books, read this, and so you are abreast with what is going on. You know what these techniques are. Please do not think that in this 40-50 hours you're going to learn end-to-end of blockchain. I will provide you a platform. How do you take off from there? But for that, you will have to also put in efforts in reading on this concept of blockchain. Okay, so let's see how does blockchain use public key cryptography. See, this asymmetric cryptography or public cryptography is an component of cryptocurrency blockchain, and these advanced techniques ensure that the source of transaction is legitimate and that hackers cannot steal a user's fund. So what is this public key cryptography? Let's see. Firstly, let's understand this. Public key cryptographic system relies on a pair of keys, and what the private key, secret. And apart from that, you have also a public key, which is broadcasted out to the network. This public key is made available to everybody. Private key is kept a secret. Okay, this system of this public key cryptography helps ensure the authenticity and integrity of a message by relying on advanced cryptographic techniques. In Bitcoin, public key cryptography is an essential part of this Bitcoin protocol and is used in several places to ensure the integrity of messages created in the protocol. It is used in creation of wallets and in signing of transaction, which there are these are the core components of any currency relying heavily on public key cryptography. Bitcoin's protocol uses what is called as ECDSA, which is the acronym for Elliptic Curve Digital Signature Algorithm. ECDSA is nothing but Elliptic Curve Digital Signature Algorithm to create a new set of private key and corresponding public key. See, this public key is then used with the hash function to create the public address that Bitcoin users use to send and receive funds. And the private key is kept secret and is used to sign a digital transaction to make sure the origin of transaction is legitimate. So till here, have you understood what this thing is? How is that? What is a public key cryptography in Bitcoin? Are we comfortable till here? Okay. Next important concept before we take a very big jump into all these things is what is proof of work. Can you hear me now? Tell me. If you're not comfortable, please stop me. Tell me, okay. Who said voice is breaking? Is it comfortable now?
With the previous topic, the public key.
Okay, fine. No problem. See, public key cryptography, I said, is an essential part of this Bitcoin's protocol. And is used in service to ensure the integrity of message created. This protocol uses what is called as ECDSA, which is the acronym for Elliptic Curve Digital Signature Algorithm, to create a new set of private key and corresponding public key. See, the private key is then used with the hash function to create a public address that Bitcoin users use to send and receive funds. This private key is kept a secret and is used to sign a digital transaction to make sure the origin of the transaction is legitimate. Could you hear what I said? Are we comfortable till here? Tell me,
Yes,
please.
sir.
Okay.
Yes, sir.
The other concept which you need to know is POW, which is proof of work. This is nothing but proof of work. See, the other major use of cryptography in the Bitcoin protocol is in computing the proof of work function. See, what miners do, they rely on computing the SHA-256 hash function for a lot of inputs until they find what is called as nonce. We will see what is this as we proceed ahead. Nonce. Until they find nonce for a given block before adding it to the blockchain. See, the difficulty of the mining process is changed by how many zeros and hashes must begin with to be added to the blockchain. This is a very unique system as it adjusts higher and lower depending on how many people are mining at any given time. And it also makes it computationally infeasible for an attack vendor to go and edit transactions that are already recorded in the blockchain. Are we comfortable till here?
Just repeat it once again, sir. Sorry.
Yeah, okay. We were speaking on this POW, which is proof of work, which is here, see, miners who are the people who look for, see what happens in a gold field. There are miners who dig the earth to pull out gold. Similar way, there are miners who work for you to extract these bitcoins. These miners rely on computing this SHA-256 hash function for a lot of inputs until they find the nonce for a given block before adding it to the blockchain. See, the difficulty of the mining process is changed by how many zeros the hash must begin with to be added to the blockchain. Now, what happens? Say, can somebody tell me what is the cost, what is the price of a Bitcoin as on today?
Around 3
40
lakhs.
lakhs.
Yes.
42 lakhs.
It is around 40 lakhs.
40 lakh.
Yes, it is
40
around, yeah, it is around 40 lakhs. And it was just 1 week back, it was around 31 lakhs. 9 lakhs it has increased in just 1 week. There is no investment in whole of this world which will give you currency in this way. I can give you a good example. About 9-10 years back from today, 9-10 years back, I had some Bitcoin personally with me. At that time, I had purchased it for 44,000. In 9 years, from 44,000, it has gone up to 40 lakhs. It is huge. Which kind of investment will give you this type of return? Nothing. Absolutely nothing will give you this kind of return. It is phenomenal. Phenomenal. It has increased 100,000 times. It has increased. It's a big investment. But the problem is, anytime it can even crash. The right time, if you were interested in buying Bitcoin, was when this COVID-19 started, which was, I think, in 2019, 19 or 20, or when did it start? 19, 20, whenever. When the COVID-19 had just begun and this lockdown had commenced, when US went crashing and UK, a lot of people infected with COVID, Bitcoin was at its all-time low. Had you purchased Bitcoin at that time, in this 1.5 year, you could have sold it for 40 lakhs. Phenomenal money you would have earned. One Bitcoin is 40 lakhs. Say, even if you have 10 Bitcoins, 400 lakhs, 4 crores, huge money. Okay, this is a bit, I'll do one thing. As we proceed ahead, I'll show you how do you buy Bitcoins, how do you trade in Bitcoins. See, please understand, it will be not for the purpose, just not for the purpose that I make you a gambler. No, it is a part of this course. I will tell you how is it that these Bitcoins are purchased. And even if you don't want to invest anything, you can buy Bitcoin with 100 rupees. Just with 100 rupees, you can invest and buy a Bitcoin, which is a small portion of a Bitcoin you buy. But even without investing even 100 rupees, you can buy anything. For free, you can earn Bitcoins. What is that you do? You do mining of this. And if you are able to extract a Bitcoin, sell it immediately, you get this 40 lakhs or whatever the price as on that day. In Indian currency, the amount comes to your account. But the minute, see, there are millions of people who are doing mining at any instance of time. So the people who are doing mining, if they're close to getting a Bitcoin, what Bitcoin does, the Bitcoin community increases the degree of toughness in the network. That is, every 10 minutes, it increases the degree of toughness in the network, so that it becomes more tougher and tougher and tougher for somebody to extract this. Don't worry, as we go ahead, I'll tell you how do you open an account, how do you trade in Bitcoins, or how wonderful is this concept of it practically, not theoretically. We'll show you practically how do you deal with these things. Okay, let's now see on another one wonderful concept which you need to know, called P2P, peer-to-peer network. See, we know that in share some files, and
Sir, your voice is breaking, sir.
they have equal power and perform the same task.
So we didn't hear after we know that.
Okay, fine. See, in computer science, we know this P2P network or peer-to-peer network consists of a group of devices that collectively store and share files. Each participant acts as an individual peer, and typically all nodes have equal power and perform the same task. And this P2P is the same thing which is used even in a blockchain. Here, every node stores, transmits, and receives file. P2P networks tend to be faster and more efficient as their user base grows larger and larger. Also, the distributed architecture makes this P2P system very resistant to cyber attacks. And you can categorize this P2P system according to their architecture. There are three main types of P2P systems. There are three main types of them. The first being unstructured, the second being structured, and the third being hybrid P2P. Hybrid P2P networks. These are the three types of peer-to-peer networks. Let's now do one thing, see a little bit on the concept of what is required for us on the concept of proof of work. Proof of work is a form of cryptographic zero-knowledge proof in which one party proves to the other that a certain amount of computational effort has been expended for some purposes, and verifiers can subsequently confirm this expenditure with minimum effort on their part. This the key feature of this moderately hard on the power or requester side, but easy to check for the verifier or service provider. This idea of POW is also called as CPU cost function. CPU cost function. You can also call it as client puzzle. And it is distinct in purpose. Say this POW is distinct from a purpose of a CAPTCHA, which is intended for a human to solve quickly, while being difficult for a computer to solve. So this is all that what you need to know about proof of work. Few other things very important which you need to know, or if you know it, please let me know so that we can skip it. Do you know what is the difference between public and private blockchain? Public versus private blockchain. Okay. See,
Sir, your voice is stopped.
private blockchain. Anybody? Okay. In an enterprise environment, it is actually really very important to know the big difference between the two. Basically, this public and private blockchain play a huge role in companies looking for the perfect blockchain type for their solution. So we will see what is a public blockchain. Thereafter, we will see what is a private blockchain. See, a public blockchain is a blockchain network where anyone can join, whenever they want. There is no restriction. Anybody can join whenever you want. Basically, there are no restriction when it comes to participation. More so, anyone can see the ledger and take part in the consensus process. This is the underlying aspect of this. Please remember it. In a public blockchain where anybody can join whenever they want, the most important thing is anyone can see the ledger and take part in the consensus process. Ethereum is one of the public blockchain platform examples. Ethereum. So if you want a fully decentralized network system, then public blockchain is the way to go. However, it can get a bit problematic when you try to incorporate a public blockchain network with the enterprise blockchain process. The best part about public blockchain is that they make sure that all the participants have equal rights, no matter what it is or whoever it is. Everybody has equal rights. Then comes our public blockchain. This public blockchain or these companies which deploy public blockchain always design every single platform in a way that offers full security. And in reality, every single day, enterprises and organizations deal with online hacks, and it's becoming a big hindrance as time goes by. There are few properties of this public blockchain, which is high security, open environment, no regulations. And the reason why you use this is, now before we see anything, you have to see what is a private blockchain. So let's see what a private blockchain is before we go anywhere ahead. See, any private blockchain is a special type of blockchain where only a single organization has authority over the network. So it means that it's not open for the public people to join in. And in reality, all the private blockchain solutions will have some form of authorization scheme to identify which is entering the platform. Basically, private blockchain solutions develop these platforms for the internal networking system of a company. If it is private to a company, it is a private blockchain. If it is open, it is a public blockchain. So let's do one thing, see a little bit more on this public and private blockchain. See, a public blockchain is permissionless blockchain. Anyone can join the network and read, write, participate within the blockchain. A public blockchain is decentralized and does not have a single entity which controls the network data. The data on a public blockchain are secure because it is not possible to modify or alter data once they have been validated in the blockchain. Some good examples of public blockchain you can say for public blockchain, you can say good examples are Bitcoins and Ethereum. These are some wonderful examples of public blockchain. Let's now see in a nutshell what do we mean by private blockchain. A private blockchain is a permissioned blockchain, and private blockchains work based on access control and restrict the people who can participate in the network. There are one or more entities which control the network, and this leads to reliance on third party to transact. In a private blockchain, only the entities participating in the transaction will have knowledge about it, whereas the others will not be able to access it. Good example of private blockchain is Hyperledger Fabric, which is created by Linux Foundation. Is Hyperledger Fabric. Please remember that. There are some differences between public and private blockchain. See, once all these concepts which we are discussing is clear in your mind, then when you get going with this concept of blockchain, bitcoins, everything becomes very, very comfortable for you. It becomes very easy and very comfortable for you. There are some differences between public and private blockchain. The first is the order of magnitude of a public blockchain is lesser than that of private blockchain. Why? Because it is lighter and provides transactional throughput. And a public blockchain is decentralized, whereas a private blockchain is more centralized. Examples are this one, Hyperledger and Ripple. And consensus algorithms such as proof of elapsed time, draft, Istanbul BFT can be used only in case of private blockchain. And transactions per second are lesser in a public blockchain when compared to private blockchain. As the number of authorized participants is less in a private blockchain, it can process hundreds or even thousands of transactions per second. And a public blockchain cannot compete with a private blockchain in terms of scalability because it is slow. Hence, and can process transactions only at a slow pace. In a private blockchain, as only a few nodes need to manage data, transactions can be supported and processed at much higher pace. A public network is more secure due to decentralization and active participation. Due to the higher number of nodes in a network, it is, I would say, nearly impossible for bad actors to attack the system and gain control over the consensus network. A public blockchain consumes more energy than a private blockchain, as it requires a significant amount of electrical resources to function and less energy and power. So these are some of the fundamental or the basic differences between public and private blockchain. Now the question, are we comfortable till here? Please tell me.
Yes, sir.
Yeah, okay. Somebody else also please tell me so that I get comfortable. That
Yes, sir.
Okay. We will see, we have been seeing about transaction, blockchain, all this. Let's see, how does a transaction get into a blockchain? See, there are several key steps a transaction must go through before it is added to a blockchain. And we will focus our attention on authentication using cryptographic keys, authorization via this proof of work, the role of mining, and more recent adoption of proof of stake protocol in the blockchain network. Now, when you see, let me just draw it out for you as to how I understand on how a transaction gets into a blockchain. What happens if I may say this is authenticated a block.
Sir, we are not able to hear you, sir.
Okay, fine. I said, am I clear now?
Yes, sir.
First, transaction is requested and authenticated. Thereafter, a block representing that transaction is created. And after this, this block which we have created is sent to every node in the network. It is sent to all the nodes. I'll put it this way, all the nodes, the wireless sign. It is sent to all nodes in the network. Thereafter, what these do, all these nodes, say I've got a node here, I've got a node here, I've got a node here, I've got a node here. And this is my block. These nodes validate the transaction. All of these nodes validate the transaction. And since these nodes validate the transaction, it needs some amount of work. So these nodes receive a reward for the proof of work, which is nothing but a cryptocurrency. And this cryptocurrency is in the form of a block which is added to the existing blockchain. Say this is my existing blockchain. This gets added at the end of it. And then what happens? The update is distributed across the network. This update, say I said this is my update. Then you can say the transaction is complete. This is how a transaction gets into a blockchain. Tell me if you've understood or you want me to tell you once again. Tell me please.
Once again, sir, after getting the transfer.
Okay, once again, I shall redraw it for you. See, first what happens, a transaction is requested and authenticated. And this transaction, a block representing the transaction is created. Let me draw a block this way. This is a block which represents this transaction is created. And thereafter, this block, which we have, let me call this block B. This block is transmitted to every node in the network. Let me take that every node means there are just 4 nodes, just for this purpose. This is transmitted to all the nodes in the network. And this, what does this block do? These nodes validate the transaction. That becomes the next step. That is, these nodes validate the transaction. I shall put a tick over here. It validates the transaction. Now, just because these nodes validate the transaction, they get a reward for the proof of work, which is nothing but Bitcoin or a cryptocurrency, basically some cryptocurrency. And thereafter, what this does, the block is added to the end of the existing blockchain. Say I have got, this is my existing blockchain. This block gets added over here at the end of the existing blockchain. And after getting added to the end of the blockchain, an update is distributed across the network. That is, it gets added, then this update is sent all across the network. And then you can say the transaction is complete. Is it fine till here? Tell me.
Yes, sir.
Yes, sir.
Okay. See, the original blockchain was designed to operate without a central authority. That is, with no bank or regulator controlling who transacts. But transactions still have to be authenticated, which is done using cryptographic keys, which is a string of data that identifies a user and gives access to their account or wallet of value on the system. And each user has their own private keys and a public key that everyone can see. Using them both creates a secure digital identity to authenticate the user via digital signature and to unlock the transaction they want to perform. This is how authentication occurs. Is it comfortable till here? Yes or no?
Yes, sir.
Okay. After this, what happens?
Yes, sir.
After authentication, the next step that occurs is authorization. See, once the transaction is agreed between the users, it needs to be approved or authorized before it is added to a block in the chain. For a public blockchain, the decision to add a transaction to the chain is made by consensus, which means that the majority of nodes must agree that a transaction is valid. The people who own the computers in the network are incentivized to verify transaction through rewards. And this process is what is called as POW, proof of work. And this proof of work requires the people who own the computers in the network to solve a complex mathematical problem to be able to add a block to the chain. Solving the problem is known as mining, and miners are usually rewarded for their work, and rewarding is only in cryptocurrency. But understand, mining is not that easy. A mathematical problem can out 1 in 5.9 trillion. That is the odds of solving a problem. So it is not that simple. It is difficult. It calls a good amount of skill and definitely huge amount of electricity for you to do. Your normal computer, desktop, laptop won't work. And even once again, all those of you who want to do mining, you have to have a dedicated system, a higher configuration system, exclusively used for mining. The whole day it has to keep doing mining. You may get a gold coin, sorry, you may get a cryptocurrency, Bitcoin or not, up to you. But once again, and also for those people who are involved, who are interested in say purchasing Bitcoins and other things, my suggestion is have a separate system for that. So, and in that system, don't have your passwords and all these things written in that, because it is then susceptible to somebody else knowing what is your password and what are your keywords and other things. So have a system separately for this. Okay, so till here, if we are we comfortable till here? Please tell me.
Yes, sir.
Okay, if you are comfortable, just for the reason of a small little break, I shall take your attendance so that it gives me some amount of breathing time in between. Okay, 777336067. 715 87332020. Yeah, percent. 15%. Okay.
Yeah.
733020. 733022. 733027. 733032. 733034. 733061.
Present, sir.
733072. 733080. 733081. 733097. 733108. 733114. 733303. Mohammed Abdul.
Present, sir.
Mohammed, again Mohammed Abdul. How come you got two names? Okay, fine. Afreen.
I don't know, sir.
Afreen,
Excuse me, sir.
tell me.
81 present, sir.
Mohammed Ahmad. Mirza Asif. Mohammed Azharuddin. Syed Alauddin Bukhari. Isam S. Hussain. Mohammad Shoaib Khan. Mohammed. Syed Nihal Hussain Madani. Maryam. Syed Kurram Mehdi. Mohammed. MOHD. These are the names. I have not written the names which are there with your email ID which you send. Automatically it picks up the name. If you have not written the name, then your roll number comes. MOHD. Mohammed. Asma Namira. Sheikh Rahmat. Then Rehma. Zubayya Rahman.
Sir, Rahma is present.
Okay. Zubayya Rahman. Syed Abdul Rab. Sajjad.
Sajjad is present, sir.
Syed Shamila.
Present, sir.
Sayyada. Sorry. Okay. Sheikh Sadullah Sharif. Sumaya. Syed. Tuba.
Tuba is present, sir.
Syed Zainul Labidin. Syed Zainus. Abdul Khadir Khan Khaled. Aslam Khan. Mohammad Muqtadir. Anybody have I missed out? It's 3079.
Sir, Mohammed.
Which one? Which is your name, Mohammed? Which one? This one?
MOHMMED. MOHD.
Yeah, okay. And who else is present amongst this? Have I missed out on anybody? 733079. 1 second. 733079. There is nobody by that name. 733079.
Yes, sir. 30, sir.
What 30?
Yes, sir. 30. 1605177. 30. Mohammed Sohail.
What is your name over here?
CSC final year, sir. Mohammed Sohail.
No, whichever year you are, that is immaterial. What is your name which is in this?
Mohammed Sohail, sir.
Muhammad Sohail, where are you? There is nobody by the name of Muhammad Sohail. I don't know.
Sir, good afternoon. There are a few things which I need to discuss with you. Is it
Yes.
right time?
Yeah, fine, no problem.
Fine. Sir, many of the students have already sent you it through office mail, means Microsoft Office mail. Probably they have already sent it. If possible, I'll tell them again to send you up with the roll numbers.
Yes. So,
That will be fine.
see, sir, there are some of them who have sent their personal mail ID. I have not added them. Two-three
Yeah,
they have sent. I have not added them. I wanted college ka mail ID. I wanted them
yes,
to.
because
I can't take
yes,
the
because
personal. Yeah.
no, because last time what they have used the Gmail, but unfortunately after your registration, before that they haven't used it. So automatically it will be nullified after 45 days if you haven't used it, the Gmail. So what we have done is that we have created that Microsoft Office mail. I've already told them again to mail you up. Provided I've already seen the problem what you are facing it, I'll tell them to use the roll number to send you again. If possible, please send them the request to join them. That will be very helpful. I'll again remind them today evening as well as tomorrow morning. Will please do it by tomorrow afternoon, if it's possible, sir, by 12 after 12 o'clock. That will be very helpful. Few of the
Sir,
students
no.
are still doing
let them drop a mail. I'll take them in. Not a problem.
All right. Okay. Because few have already, because many of them already don't have that Gmail, what do you call Microsoft. So I'll have to create that one again in the evening. Then I'll send them. Probably they'll send you back in the evening or in the morning. That
No
please
problem,
do that.
no
That will be
I'll
very
do
helpful, sir.
I'll do that. No problem.
Right. This is what I have to tell you. We probably when you send the link, I'll upload it on my YouTube channel, and I'll also send you the link which is there. It's very thankful. Please continue with the class, sir, if it is there.
Okay. And see, tomorrow, yeah, anybody have I missed out on this?
Yes, sir. You have missed out me. Roll number 4. It's the second one from the top.
4, okay. Anybody else? Don't put it in your chat box or anything. Just speak out to me where whom have I missed out. If I missed out anybody.
Sir, Mohammed, sir.
What's your number?
Sir, Mohammed, sir. Mohammed.
There are so
Everybody
many.
is Mohammed. Everybody you have written as Mohammed. Mohammed. You should go with your roll number by. Please try to understand. This is the problem we are facing it.
Which is your? Where is your name?
In the username, what
Full
you are
capital,
sending
Mohammed.
it.
Sorry.
Full capital, sir. Below Sohaib Khan.
Okay. Yeah. Okay.
Mohammed.
Okay. Fine. No problem. Anybody else? Okay. Now, before we go ahead, I just wanted to ask one thing. Tomorrow, once again, we have our class from 2 to 4. Is it that you guys are free anytime in the morning tomorrow? Because I've got an office meeting at 2:30 onwards. The last minute developer. There's some people from overseas who have come. The last minute, some office, very urgent office meeting. Is it possible that you are free anyway in the morning?
You want to conduct in the morning session?
Sir, morning.
Morning 11:30 to 1:30. 11:30 to 1:30. Will it be fine for you?
Okay, 11:30 to 1:30. Then it will clash with the time on the credential which I have shared with Saida. I had given her 11 o'clock. Saida will do one thing. Then your session will have it at 10 o'clock instead of 11. Is that fine, Saida?
Okay, sir. I'll
Yeah.
update it in the group.
Yeah, you can
Because,
tell them
it's,
the credential remain the
because
same.
it's-
It will be, yeah.
Yeah, you tell, sir.
Okay, the credentials remain the same, Saida. It will, we'll have instead of 11, we'll have it from 10, and the same session from 2 to 4. The credential will be the same. I'll change the timing from 2 to 11:30, 11:30 to 1:30. Is that?
Yeah, because it's Ramzan time, so I can expect by
Yeah,
11
that's
o'clock everybody will be there. So I'll put it at 11:30. So
Yeah,
what I'll
fine.
do that one, you just update that. I'll post in the group also, taking the note of you that if you haven't registered, please send it from this so and so mail. If you don't have any mail, I'll just share a Google Sheet. Please paste your mail ID. I'll just create a Microsoft Office mail for you. By evening, you can just mail to the sir. By morning, he will just check and reply back to you.
Yeah, that's not at all a problem. But please get registered because there's no other way I can update your attendance otherwise. There is
All right, no
absolutely
issues, sir. No issues. No issues. I'll just tell them. I'll just tell them. Yeah.
Okay.
All right. Okay, thank you.
Yeah. Anybody wants to ask anything with regard to what we have done today? See, another maybe 1 or at the max 2 more sessions when there will be these heavy theoretical concepts. After that, it is a short rest. Everything is going to be practical. It will be 100% hands-on where we will do programming using Solidity, quite a bit in Python, quite a bit in Solidity, little bit in JavaScript. So that, most of the programming will be in Solidity. Even because developing smart contract is in Solidity, we will develop smart contract, a small little smart contract. We will do some, this encryption, decryption, all these things we shall do so that you are also aware as to how do we do it. And once again, I shall request all of you, please do one thing. What you need to do from your side is you need to get hold of some published literature so that you are able to read what it is. Otherwise, this is of absolutely no use what I'm telling, because it is practically impossible for me to convey end to end of everything. I shall definitely give you a platform where you can take off from whatever has been taught. But we will not miss out on anything, especially when you do practical, because it takes a little bit of a time for you to do practical. It will be better. It will be better if you can refer to some published literature so that you are able to take off on your own. Anybody wanting to ask anything? Fine. I shall only, before we sign off, I shall request Saida tomorrow, once again, like we said, it will be at 10 o'clock, and only all those who are interested, let it not be a fish market here. So only all those who are interested, kindly convey the same potential to your friends so that all those who are interested can join at 10. So, and that will be from 10 and 11:30 onwards, we'll have the same session, 11:30 to 1:30. And definitely,
Okay,
tomorrow at 6 o'clock, you have got the first MCQ graded test. Okay, and also what we will do from tomorrow onwards, there will be assignment for you. And assignment is not that you do something and mail it to me. I don't want anything by mail. I want you to upload it on this canvas so that there remains a proof as to when is that you're submitted and what is that you're submitted. Okay, so I want you to upload it on the canvas. Even if you send a mail to me, I will not reply to you back. That means it has gone to trash. You cannot take things which are convenient to you. You should take things which is required. Okay, anybody wanting to ask anything, any doubt with regard to what we have done today? Any clarification to what we have done today? Okay, fine. We pack up a session for today. We will catch up tomorrow at 11:30. Thank you, friends. Have a nice day.
Thank you, sir. Thank you very much.